Good morning, Tamina Khan is here in TK Maths is Fun. In today's video, which is video number 4 on the topic of equilibrium and acceleration under concurrent forces, it is a syllabus of A-level mathematics M1. So the last video 4 is on the past paper question. You can see what is in the other 3 videos. The link will be given in the description below. In this video, I have kept 3 questions of past paper. 2 questions I will explain to you and 1 question is for your checking your understanding basically. So let's solve this question. These questions are comparatively easy because we have not finished or studied friction as yet. So you will see that I have taken mostly one part of the question only. So now whatever is written here is already described. Whatever is described here is already drawn here. So we have to find basically the acceleration of A and tension in the string. And both planes are smooth. Weight is given here. An angle with the horizontal surface is also given of the inclined plane. So let's see here. So first of all, we have to resolve forces parallel and perpendicular to the plane as we have seen in the previous 3 videos. So let's resolve particle A first. So the weight acting downward will be 8 kg because the weight is 0.8 kg. So it will be 8 Newton, right? So now I'm resolving perpendicular to the plane and parallel to the plane. So this will be 8 sine 30 as this angle is 30 degree and we have seen how to resolve in the previous videos. And this is 8 cos 30. Now similarly for particle B, the weight is acting downward, right? And it will be what? 12 Newton. Absolutely right. Resolving perpendicular to the plane and parallel to the plane. So this will be 12 cos 60 and this one will be 12 sine 60. Now because the particles are released from rest, right? Since the weight of particle B is heavier, I will consider that it is moving down in this direction when it is released. If the acceleration comes positive at the end, then it means the assumption we have taken is correct. Otherwise, if acceleration comes negative, it means the particle actually started moving in this direction. So for the time being, I'm considering that B started moving down. Okay. So now let's see. So for particle A, I will apply the Newton's second law of motion. And let's write here in the string the tension is T. Okay, for both particle A and B. So since particle A is moving up, the tension is larger than the force parallel to the plane, which is 8 sine 30. So I will write T minus 8 sine 30 is equals to 0.8A. 8 sine 30 is equals to 4. So 4 plus 0.8A, my equation 1. Now I will see for particle B, same concept, Newton's second law of motion. In this case, because we are taking B is coming down, so the force due to weight is larger than the tension. So now this time I will write 12 sine 60 minus T equals to 1.2A. And this thing is equivalent to 6 root 3 minus 1.2A equals to T. So this is equation 1 and 2. I will solve them together. So it will become 4 plus 0.8A is equals to 6 root 3 minus 1.2A. So it will become 2A is equals to 6 root 3 minus 4. Pick up the calculator and you get the answer 3.196. Correct. So in 3 significant figure, it will be 3.20 meter per second square. So answer is in 3 significant figure. Now to calculate the tension, you can substitute this value of A either in equation 1 or 2. So I am substituting it in equation 1. So T is equals to 4 plus 0.8. Let's substitute the value. Remember, don't substitute the rounded off figure, the actual figure, so that your next answer is not compromised. In 3 significant figure, so we got the tension and we got the acceleration. Okay, so now let's do the second question. This question is interesting because it includes the concept of SWOT equations also, which we studied in chapter 1. So let's see what is given here. Particle P has mass 7 kg. I'm just writing here for my reference. It means the weight is acting downward and weight will be what? 70 Newton. Right. For particle P, the weight is 3 kg. Let me write here for myself. So its weight is 3 kg and it will also act downward. So it will be 30 Newton. Okay, definitely tension will be acting upward on both ends. Both the particles are 0.4 meter above the ground and from the table 0.5 meter below. It is written here. Initially they both are at rest. The two particles, and we have to find the acceleration of the particles and the speed of P immediately before it reaches the floor. It means they are released after some time, right? So now what we will do, again we will apply Newton's second law of motion on both ends at P and Q. Now P is heavy, so it will start moving down here in this direction. So let's see for particle P first. F is equals to ma, right? So because particle P is coming down, so I will write 70 minus T is equals to 7a. So this will be 70 minus 7a is equals to T, equation number 1. Now I will write the same equation for particle Q. So particle Q is moving up, so tension is larger than the weight. So I will write here T minus 30 is equals to 3a. 30 is equals to 3a. So T is equals to 30 plus 3a. So solving them together simultaneously, it will give me, just 1 minute, this is my equation number 2. So 70 minus 7a is equals to 30 plus 3a. Just a minute. Okay, so now pick up the calculator. So it is 70 minus 30 is equals to 40 and this is 10a. So acceleration is equals to 4 meter per second square. Now you have to calculate what? Tension also. So now the tension will be equals to, you can substitute in any equation, 1 or 2. I'm using equation 1. So I will get 42 Newton. So the tension is 42 Newton. It is not asked. I'm just calculating it. And acceleration is 4 meter per second. Now let's see the question. Part 1 is asking speed of P immediately before it reaches the floor. So when particle P will come here on the ground, what will be the speed at that time? So let's use a SWOT equation. And what information do we have right now? That initially they were at rest. So U is equals to 0. We have to find out distance covered is equals to 0.4, right? And acceleration we have just calculated is 4. So we can use the equation V square is equals to U square plus 2AS, right? So we have to calculate U is 0, 2AS. So we got V is equals to root 3.2, which is equivalent to 1.789 meter per second. So this is the velocity of particle P when it reaches the ground, and definitely Q is also having the same velocity. Now what happens? See here. This is part 1 finished. In part 2 we have to find out Q comes, we have to determine whether Q comes to instantaneously at rest before it reaches the pulley. So what is the situation now? When P has covered this distance 0.4 meter, Q has also covered distance 0.4 meter, right? Now at this point, the velocity of Q is equals to same as the velocity of P when it reaches the ground, which is equals to, which is equals to 1.789. So I will take it now. Why did I write U? Because now Q is going up. So this will be considered its initial velocity, right? So now we have to check either it comes instantaneously at rest. So if I put V is equals to 0 and the distance covered is less than 0.1. Why 0.1? Because this hole is 0.5, Q has already covered 0.4 meter, so only distance left is 0.1. So if distance come less than 0.4, then we can say yes, Q will come instantaneously at rest before reaching the pulley. So let's find it out. So for second part now, for Q, U is 1.789 and we are assuming that when V is 0, what will be the distance? So V is 0 and A will be minus 10 now. You know why minus 10? Why not I'm taking 4? Because the moment P will reaches the ground and Q was here, now the string will be slack. It will no more be taut. So it will be under the condition of free fall. So acceleration will be minus 10 and distance we have to calculate. So I will use here again V square equals to U square plus 2AS. And U is 1.789. Please pick up the calculator. Plus 2AS. Okay. So S is coming 0.16. Now this distance 0.16 is more than 0.1. So I can say since 0.16 is greater than 0.1, hence what? The particle will not, or particle Q will not stop instantaneously before reaching the pulley. Hence Q will not, copy down from here, will not instantaneously come to rest before reaching the pulley, right? Now your time to test your understanding. This is the question. I have solved it, but you can put the video on pause and check your understanding. So I'm going to show you the solution, but you check it after you finish it. Okay. So here is the solution and I'm sure you would have gotten it correct, 100% marks. Thank you very much for watching the video. Next video will be on the topic of friction and then we will have interesting challenging question of past paper to solve. Take care. Allah Hafiz. Don't forget to share it with your friends and press like and subscribe button. Allah Hafiz.